All right, a little bit different take on motion problems this time and the train problems. Slightly different in this lesson. So in this first example, we've got two trains that leave Minneapolis at the same time. One traveling east and the other traveling west. I'm going to just draw a little picture so that we can kind of visualize this a little bit. So here's Minneapolis. We've got one train that heads east, so it's going this way, and one train that heads west, so going this way. Okay? The eastbound train travels 40 miles an hour, and I should maybe draw this to a little bit better scale. So the eastbound train travels 40 miles an hour. Okay? I don't know how far they're going to get, but I know they're going to travel 40 miles an hour. The westbound train travels 50 miles an hour, so the westbound train is traveling a little bit faster. So what should happen is, in the same amount of time, if they both travel for an hour or they both travel for 2 hours, this train headed this direction will not get as far as the train headed this direction because the train headed to the west is traveling faster. So they will be able to get farther in the same amount of time. Okay? So I'm going to call this train train A and this train train B. So the one that's heading east is A and the one that's heading west is B. Okay? I know that the eastbound train travels 40 miles an hour. I know that the westbound train travels 50 miles an hour. I don't know how long they're each going to be on the road, but they are leaving Minneapolis at the exact same time. So, however long they're going to be on the road will be the same for, or on the track, the same for A and the same for B. Okay? Again, distance equals rate times time. So, my distance here will be 40 times t, which is 40t. And for train B, it'll be 50 times t, which of course we know is 50t. Okay, now what we haven't used is this. How long will it be before the trains are 180 miles apart? So if you picture this picture, what's happening here is that distance needs to be 180 miles. Okay, now, if you think about this, I don't know what A's distance is, but I know that this is 40t, and I know that this is 50t. Okay, so from here to here is 40t, and from here to here is 50t. And together, when I take that 40t and that 50t, they have to add up to 180 miles an hour. So, or 180 miles. So 40t plus my 50t, train's A distance plus train B's distance, has to add up to 180 miles. So when I solve that equation, then I just have 90t equals 180, divide by 90, and t equals 2. And since our speed is miles per hour, and we're talking about time here, this would be 2 hours. So they're going to be on the road, or on the track, for 2 hours before they catch up to each other. Okay? The next one's just a little bit different. Two cyclists begin traveling on the same path, headed in the same direction. One travels at 15 miles an hour, and one travels at 13 miles per hour. How long will it be before they are 10 miles apart? All right, so this is a little bit trickier here. So we have the first cyclist here. Let's call it cyclist A. He travels, or she, that cyclist, travels 15 miles an hour. So they're leaving, they're traveling 15 miles an hour. Okay. The next one, cyclist B, goes the same route, so I'm just going to draw them below each other so we can see. They travel 13 miles an hour, so not as fast, okay? So the next one's not traveling as fast. So basically, in the same amount of time, they will not get as far of a distance. So let's say they only get to there. And what you need to do is you need to have this distance right here be 10 miles, okay? So let's call this cyclist A. Travels at 15 miles an hour. I don't know for how long they're going to travel. I don't know that. But I know their distance is their rate times their time, so this should be 15t. Cyclist B, I know that it's only traveling 13 miles an hour. I don't know how long it will be on the cycle for, on the road for, but I know that its distance will be 13 times t, which is 13t. Okay, I know that cyclist B will be farther behind cyclist A. In fact, it will be 10 miles behind cyclist A. Okay, I don't know this distance either, except for that it's 15t. And I know that this distance is 13t. Okay, so you can do a couple different things. You can take the 13t plus the 10 miles and set that equal to 15t. Or you could take 15t minus the 13t and set that equal to 10. It really doesn't matter. So if I look at my picture, it might be easier to picture how 13t plus 10 miles has to equal 15t. Okay, and then I will subtract 13t. So 10 equals 2t divided by 2, and t equals 5. And again, you're looking at miles per hour, so your units of time in this case would be hours. It's a long time to be on a bike. But that's what that should look like.